Within 3HP, we have developed 3 generation systems that are able to provide heating, cooling and electricity to multifamily residential buildings with an on-site renewable share of 80%, aiming to reduce costs by 10 to 15%. Our heat pumps make use of natural refrigerants, which reduce the global warming potential compared to heat pump technologies available in the market today that use highly polluting synthetic refrigerants. During 3HP, we have developed 3 electrically driven heat pumps coupled with photovoltaics, 2 solarized slurry systems, one using propane and one using CO2 for refurbished and new buildings respectively, and 1 dual sourcing system able to provide heating and cooling with a reversible propane heat pump. 2 of those systems are tested with an advanced energy management system, which allows to decrease the operational cost by 10 to 15%, thanks to the modern predictive control and the use of variable electricity prices. So the systems are tested in Switzerland at the laboratory facilities of SPF and in Spain at the laboratory facilities of IREC. This is the concise cycle test facilities here in Switzerland, where we have tested 2 solarized slurry heat pumps, one based on propane and one based on CO2, targeting buildings with high share of space heating and buildings with high share of domestic hot water demands. Both systems use solar thermal collectors as the only heat source for the heat pump, and we use an ice slurry vessel to compensate times when solar radiation is not enough to provide heat to the heat pump evaporator. To produce the ice slurries, we use the supercooling method that we have successfully implemented thanks to the novel isophobic coatings that have been developed within the project. The solarized system using the supercooling method is the first of its kind and has the potential to be a breakthrough technology if we successfully implement it in real buildings. The main innovation of the CO2 system is the tripartite gas cooler, which allows to provide domestic hot water and space heating demand simultaneously and at a very high efficiency, and the supercooler, which allows to supercool water thanks to the coatings that delay the formation of ice.
This is CELAB, the laboratory of IREC in Tarragona in Spain, where we are testing the third 3HP system. It's the dual source system. It's based on a propane heat pump, which is reversible, so it can provide both heating and cooling, and therefore it's more suited to the climates of Southern Europe, where we have both these needs. Its main innovation is the dual heat exchanger that is able to connect both to a geothermal borehole or to use the ambient air. So it uses both of these mediums as heat sources in the heating season or as heat sinks in the cooling season. And therefore we can choose at every moment which is the most efficient source between the air or the ground, depending on their temperature. The 3HP systems include advanced controls that manage electricity, heat and cold in an optimal way. These controls are based on model predictive control that manage to reach up to 15% of economic savings, and they can do so because of their 2 main features. So the first one is the access to forecast, for example, of the weather or the electricity price for the next day. And the second are integrated models of all the systems, including the thermal and the electrical devices. And it can use these models to project the behavior and find the optimal trajectory for the next day. In this way, the advanced energy management system makes a smarter and more informed decision than a standard control would, and therefore it reaches 15% of economic savings and as well increase the share of renewables up to 80%.
In the 3HP project, we have successfully validated complex 3-generation systems based on natural refrigerant heat pumps using the concise cycle test. The test we conducted is a necessary step before bringing the technology towards a real building, which will be the next step on both technologies. In the case of the dual heat pump, the system is ready to go to the next step, while in the case of solar ice slurry system, we still need an intermediate step where we can test the system using a real ice crystallizer and ice slurry vessel.